This video is a refresher video on simplifying radicals. It goes along with the remediation worksheet on simplifying radicals and imaginary numbers that you'll need to complete to get a an exam retake on that section. So let's look through our first example here. On simplifying radicals, we're going to do the square root of 112. And how we approach this, we're going to look at this number 112. We're going to break it down into factors. So if you remember when we went over this in class, I always said to break these numbers down, always see if they're divisible by 2. And if they're not, if they're divisible by 3. And if they're not, are they divisible by 4 or 5? And so on. So we'll start off with, is it divisible by 2? It is, because it is an even number. Any even number is always divisible by 2. So we divide 2 into 112, we get 56. Is 56 divisible by 2? Yes, it is. And 56 goes into that 28 times. Is 28 divisible by 2? Yes. 2 goes into 28 14 times. And 14 is also an even number divisible by 2. So you see we'll get 2 times 2 times 2 times 2 times 7. That is the factorization of 112. So we can rewrite this. If we have 2 times 2 times 2 times 2, that is 2 to the 4th power times 7. 7 being a prime number, we can't break that down anymore. So now we know we can rewrite 112 as 2 to the 4th times 7. So let's go ahead and do that. So 2 to the 4th times 7. Now, we also discussed when we were taking a square root, that we also have a 2 up here in the corner. Just like if we're taking a cube root, we have a 3 up there in the radical sign. That part, keep dropping everything. Okay, for our instance here, this would be a square root, and the square goes there, 2 to the 4th times 7. So we can break this up, because one of our goals is to get the number inside here, our exponent inside here, to match what we have out here on our radical sign. So we can rewrite 2 to the 4th as 2 squared times 2 squared times 7. 2 squared times 2 squared equals 2 to the 4th. So let's rewrite this again. So we have our square root. We have 2 to the 2nd times 2 to the 2nd times 7 on the inside. Now, why did I do that? Because when I have the exponent that matches this number here that goes with my radical, this is a square root. If I have a square here and a square root, I can pull the base out front. So I have, again, a matching, the exponent matches out here, so I can pull that out front. So what I end up with is 2 times 2 times the square root of 7, and 2 times 2, of course, is 4. So my answer to this, when I'm simplifying this expression here, the square root of 112, my answer is 4 times the square root of 7. The steps I took was I did the factorization, the factor tree, if you will, and I came up with 2 times 2 times 2 times 2 times 7. That's the factorization of it. I broke it into 2 times 2 squared times 2 squared times 7, because that way my exponent matched the number inside my root. I was able to pull it outside there and get 4 square roots of 7. So let's try that process with another example here. Next example I want to work is the square root of 245. And so we're going to find our factorization there, our factor tree, whatever you want to call it, over here on the right side. We start off by, is this number divisible by 2? It is not. It has to be an even number to be divisible by 2. Is it divisible by 3? It is not. How do we know? We add the individual digits here. 2 plus 4 plus 5. 2 plus 4 plus 5, that equals 11. 11 is not divisible by 3, so the larger number is not divisible by 3. Is this divisible by 4? No, because it's not even. Is it divisible by 5? Yes, it is. Any number that ends in 5 or 0 is divisible by 5. So let's break that down. 5 goes into 245. Did that off camera here, 49 times. Okay, now 49 screams out at me, that's 7 squared. So 7 times 7 is 49. So now looking at this, I have my factorization. It is 5 times 7 times 7, or I can rewrite that as 5 times 7 squared. So I'm going to rewrite my 245 is 5 times 7 squared. And remember, I'm taking a square root, so I have that square up here as well. So anytime this number out here matches my exponent, I can pull my base out front. So I'm going to end up with 7 square root of 5. And that is my simplified radical. So if I'm simplifying the radical of 245, I end up with 7 times the square root of 5. And do one more example here. I want to do a cube root. What I mean by cube root, square root was when I took a square root. This is the root, I took the square. So if I'm taking the cube root, that's a cube root right there. Okay, so I have 2 root, cube root. Okay, so we are going to do the cube root of 648. The process is still the same. I'm going to do a factor tree over here for 648. Is it divisible by 2? Yes, it is. That goes 324 times. Is 324 divisible by 2? Yes, it is, because it's even. And it goes 162 times, I believe. Let me check my math here. Yep. And I should have done that this way. Okay, is 162 divisible by 2? Yes, it is. And that goes in 81 times. Right there, 81 kind of screams out at me as a square root of 9. Okay, 9 times 9. But let's remember, we're not doing a square root. So let's break it all the way down. 9 is 3 times 3. So my factorization of 648 is 2 times 2 times 2 times 3 times 3 times 3 times 3. If we did that math, that multiplication, we come out with 648. So I'm going to have 2 cubed times 3 to the 4th. That is the same thing as 648. So let's rewrite that in here. So I'm going to do the cube root of 2 cubed times 3 to the 4th. Now, when I have a number in here, an exponent that's larger than out here, I'm going to break this down. So I'm going to break that 3 to the 4th down to 3 to the 3rd times 3. 3 to the 3rd times 3 is the same as 3 to the 4th. So I broke my 648 down into 2 cubed times 3 cubed times 3. Now when I do that, if I have the exponent that matches my root number out here, I can pull out that base. So I pull that 2 out and pull that base of 3 out. I get 2 times 3 on the outside, or 6 times the cube root of 3. And that is my answer to the cube root of 648 is 6 times the cube root of 3. So hopefully those few examples served as enough of a refresher in simplifying radicals. There's going to be one other refresher video that goes along with this, and that goes on the imaginary numbers. After you watch those 2 videos, this one and that other one, you should be ready to tackle the remediation worksheet for section 1 of Unit 6.